this video, we will discuss about smallest range covering elements from K lists. First, let's understand the question. You have K lists of sorted integers in non-decreasing order. Find the smallest range that includes at least one number from each of the K lists. We define the range a comma b is smaller than range c comma d if b minus a is less than d minus c, or a less than c if b minus a is equals to d minus c. So what they are saying is that we are given K lists in our question, and we need to find a range such that that range contains at least one element from each of these lists, and that range should be the smallest. That means we need to find a smallest range, okay, a smallest range, and that range should be such that it contains at least one element. It should contain at least one element from each of the list, right? So let's suppose, for example, I have this range 0 to 5. So if you will see that from this array 1, 4 will be present within this range, right? From this array 2, 0 will be present within this range. From this array 3, 5 will be present within this range. So I can say this is a range which is containing at least one element from each of the list. Now you need to identify all those ranges, and whichever is the smallest range, that should be your answer, right? So let's see. How are we going to do this? Now let us suppose that we are having only these many elements. We are considering all the arrays of length 1. So what elements we are having? 4, 0 and 5, right? Now in this case, if I plot them on a number line, it will be 0, 4, 5, right? Now what should be the range from this such that it contains at least one element from each of the arrays? That will be 0 to 5, right? Because 4 will lie in between somewhere of 0 and 5. 0 is present here and 5 is present here, right? So this is a range which is covering at least one element from all the arrays. Now if you closely look here, what we did was that whatever were our minimum and maximum element, that became our range. 0 was the minimum element and 5 was the maximum element. So this became our range. So we considered the maximum element and the minimum element. Now what will be our range? Our range will be the difference of maximum minus minimum, right? So in this case it is 5 minus 0, which is 5. So 5 is our range, right? Now let us suppose we are considering this much array, meaning all the arrays of length 2. Then what all elements we are having? 4, 0, 5 and 10, 9, 18. So this is the first array, this is the second array, and this is the third array. Now in this case, how you will identify the range? So see, we saw what is our range. Our range is the difference between the maximum element and the minimum element, right? Now we need to find the smallest range, right? So to minimize the value of range, if we increase the value of minimum, then we can minimize this difference, right? Or if we decrease the value of maximum, then also we can minimize our range, right? Now in our question, it is given to us that all the array elements are sorted in increasing order, right? So that means I can increase my minimum element in order to minimize the difference. And if I will minimize that difference, then eventually I will be able to get a smaller range, right? So when I have taken these elements, so before these elements, my minimum was 0 and my maximum was 5. So I am saying that I will increase this minimum. And if I will increase this minimum, then there are chances that I can get a smaller range. So now what you will change this minimum to? What you will use in place of 0? So we will use 9. Now why only 9? Why not 10 or 18? We wanted to find a range which contains at least one element from each of the list, right? If we will take 10 or 18, then in that case, none of the number would be present from the second array, right? So that's why the only choice that is left to us is to use 9 in place of 0, right? So now at this point, from array 1, we have taken 4, from array 2, we have taken 9, and from array 3, we have taken 5, right? So now out of these, what is your maximum and minimum? So maximum is 9 and minimum is 4. So now what will be your range? Your range will be 9 minus 4, which is 5. But initially also it was 5. We got the same range. Now let's suppose this range was smaller. Then in that case, we would take this range. If this range is larger, then we won't consider it because we want to find the smallest range. Now, in this case, these two ranges are same, right? in the question it is given to us that if two ranges are having same value, then in that case you have to consider the one which is having its minimum value as small. So in this range our minimum value was 0, and in this range our minimum value is 4. So we will consider this one. So whenever my range is equal, I won't update it. Whenever my current range is greater, then I won't consider it. Only when it is smaller, only then I will update my minimum range, right? Now at every step what we are doing is that whatever was our minimum, we are taking the element next to it so that we can increase our minimum and minimize our difference, or we can say minimize our range. So at every point I am having one element from each of the array. Out of these I am taking the smallest and the largest element, and I'm calculating their difference, and I'm checking what is the range that I am getting, whether it is smaller, equal, or greater. So I want such a data structure which can hold these elements, right? And it should be able to give me the minimum element, right? Because at every point I am changing my minimum element, right? So what is that data structure? That is min heap, right? Min heap will always store the smallest element at the top. So if I store these elements in min heap, I can get the smallest element, which will be the top element of our min heap. Now, how will you get the maximum element? So maximum element will be present in your min heap at the last, and we cannot access the last element directly. So whenever we will be inserting our elements inside min heap, we will keep the track of maximum element. We will declare some variable maxi, and whenever we are pushing into our min heap, we will update this variable, that if the number that we are pushing in our min heap, if it is greater than maxi, then maxi will be updated to this number, right? So now let's see what are we doing. So I said first of all we need a min heap. So min heap will be implemented through a priority queue. So first of all you need a priority queue. Let's suppose its name is PQ, where you are inserting your elements. Now you will take one variable range, which will store the minimum range, right? So its initial value will be your maximum integer, right? Then you will create two variables, low equals to 0 and high equals to int max, right? These two, low and high, will denote your minimum range, the start value of your minimum range and the end value of your minimum range, and at the end we will return this low and high, right? And I said that whenever you will be pushing any element in your min heap, you will have to keep the track of maximum element. So we will create a variable maxi whose initial value will be int min, right? And we will update this element. Now what you will do is that you will iterate in your nums array. All the arrays are present in one array. So this is your nums. So we will iterate in nums. So I equals to 0 to nums dot size, right? And then what we'll do is in our priority queue, we will push our element. What will be our element? Nums of I of 0, the first element of each array that we will push. And I said whenever we will push, we will update maxi. So we will update maxi also here. So maxi will be equals to max of maxi comma nums of I comma 0, right? So after this loop, you will have all the first elements of your all the arrays in your priority queue, right? Next, what we'll do is we'll do while our min heap is not empty, right? While it is not empty. So what you will get, the top element will contain the minimum variable mini, right? PQ dot top will be your minimum element, right? Then you will check that is this minimum and whatever is our maximum, what is the range value that they are giving? Is it smaller, greater, or equal to than the range that we are having in this variable, right? So once you have taken the top, you can pop it out, right? Why we are popping it out? Because what I said, that every point we will change this minimum to the next element, right? So that's why we are popping it, and after this we will push the next element, okay? So now you got the minimum. Now you will check that if your difference between maximum and minimum is coming out smaller than range, right? If it is smaller than range, then in that case we will update our range. So range will become maximum minus minimum, right? And since our range is updated, so we will have to update low and high also. So low will become mini and high will become maxi, right? So this is what we'll do. if this difference comes as lesser than range, right? Now what we'll do is, now we need to insert the next element, the element after mini. So now if you see here, when we inserted the first elements of our arrays inside our heap, so it would be 0, 4 and 5. So our minimum was 5. Now we want to insert the next element. What is the next element? 9. We want to insert 9 in our min heap. But how do you know that which element has to be inserted? In your min heap, only this element is present, 0. You don't know which array does it belongs to and what is its index in that array, right? So to find out the next element that has to be inserted along with the element, we will have to store two more things in our min heap, right? So in total, we will store three things. The first one will be the element, right? The second one will be the list, and the third one will be the index, right? So this will be your element, which in this case is 0, right? Second will be the list. List meaning in which list is 0 present. So this was your list 0, this was your list 1, and this was your list 2, right? So this list will contain 1. And then index. Index is what? That what is the index of this element in this list. So this was list 1 and the indexes were 0, 1, 2, 3. So its index is 0. So for this 0, you will store 0, 1 and 0, right? So this will be present in our priority queue. So here when we are taking the top element, then instead of mini, we will get three things now, right? So instead of mini, we will get mini, your list and your index, right? So now we need to insert the next element. Now let us suppose that your minimum element was this 20. There is no element next to it. It is the last element of this array. So you don't have anything to insert here. So we will stop here. Why we are stopping here? Because since we do not have any element after 20, then we cannot proceed further. Because if we proceed further, then there won't be any element present from array 1. But in our case, we wanted at least one element from all of the lists, right? So whenever we are at the last index of any array and we do not have any other element to insert, in that case we will stop. So here we will check that if your index, right? Index is what? Index you got from here, right? This will be the index of 0 in the list. So if your index is equals to nums of list dot size -1, right? So this list is the array in which 0 is present and index is the index of 0 in list. So if this index is equals to the index of last element in list, then we will break out of our loop. We will break out of our while loop. So otherwise you will push your next element, and we are inserting three things now. So the first thing is your element. So your element will be nums of list of index plus 1, right? Then next is the list. List is the same. And the next thing is your index. Index will be now index plus 1, right? So this is what we will push. And when we inserted the first elements of all the lists here, here also we will insert three things. So this will now become, so you will insert the element, then you will insert the list, which will be I, and then you will insert the index, which will be 0, right? So now we pushed the next element. And as I said, while pushing, we will update the maximum also. So we will update maxi. Maxi will be equals to max of maxi, comma, nums of list of index plus 1, right? And this is what we are going to do at every iteration. And at the end, you can simply return your low and high, which will denote the smallest range, which will denote the smallest range containing at least one element from each of the list. Okay. So I hope you got it. So now let's code it out. So first of all, we have to create a min heap, and min heap is implemented through priority queue. So we will create a priority queue. Now inside our priority queue, we need to push three things, right? One is the element, other is the list, and other one is the index, right? Three things. So now in C++, we have a data structure called tuple, which is capable of storing three values. And in our case also, we need to store three values. So the type of our priority queue will be tuple, and all of this will store integer values, right? And by default, priority queue creates a max heap, but in our case, we need to create a min heap. So we will write vector tuple int, and then greater angular brackets, and we will name it PQ. So this is the syntax for creating a min heap. Now we'll create a range variable for storing the minimum range. Its initial value will be int max. Then we need two variables, low and high, for storing the start and end of our range. So low will be 0 and high will be int max. Why we have taken the low as 0? Because in our array there will always be positive numbers, right? Next we want a maxi variable to keep track of the maximum element. So initially it will be int min, right? Now we will loop for the first elements of all our arrays. So I equals to 0, I less than nums dot size, and I plus plus, right? And then in our priority queue, we will push the first elements. So it will be nums of I of 0, then I, and then 0, right? And then we will update our maxi. So maxi will be equals to max of maxi, comma, nums of I of 0, right? Now we have got all the first elements in our queue. Then we'll check that while our PQ is not empty, right? We'll take the top element, which will give us the minimum element, right? So auto, your first will be your minimum element, then next will be list, and next will be index, right? This will be your top element. Then we'll pop this out. We'll pop this element. Now we'll check that is the difference between the maximum and minimum lesser, greater, or equal to the range. So if your maxi minus mini is lesser than the range, then we'll update the range. So range will become maxi minus mini, low will become mini, and high will become maxi, right? Now we need to insert the next element of mini, right? So if mini is the last element, then we need to break also. So we'll check that if index is equals to nums of list dot size minus 1, then we will break. Otherwise we'll push the next element. So pq dot push, and that will be nums of list of index plus 1, list will be same, and index will be plus 1. And then we'll update the maximum variable. So maxi equals to max of maxi, comma, nums of list of index plus 1, right? And at the end you can return low and high. So we'll do vector, uh, let's suppose r, and it will be low, comma, high. So we will return r. So now let's run this. So our test cases are accepting. Now let's submit this. So it got accepted. Thank you so much for watching.